So remember from lesson 2, when we were trying to figure out whether or not there were relationships or associations between two different variables in a data set, two different columns, then what we would do is we would plot it. And what we would do is we'd use a scatter plot. And then look at it and see if we can discern any types of patterns. So is there some kind of linear relationship between the x and the y variables? If so, then we would calculate the correlation coefficient in Excel. We wouldn't do it by hand. And then based off of that correlation coefficient, we might ask ourselves, is it a good candidate for linear regression? So the closer to positive 1, the closer to negative 1 for the correlation coefficient, then we, and looking also at the pattern of the scatter plot, the actual dots in the plot, then we would try to say whether or not we could try to fit a straight line to the data, which would be a good candidate for linear regression, a linear relationship between those two variables. So to do that, when we do have an x and a y, then we would want to look at simple linear regression, and I put simple in quotes. It is called simple linear regression, but I want you to understand what it is and also why it's called simple. So linear regression in general, what it tries to do is simply find a straight line that is a good, quote, fit to the data points. So we're trying to best fit a straight line to those data points. And we'll talk more about what it means to be a best fit line in a little bit. So we're approximating the relationship between the two variables with a straight line. And it's called simple because there's only one independent variable, one x variable. So the x is influencing what happens to the y variable, the dependent or response variable. So it's called simple because only one x independent variable. When we get to multiple linear regression, we will have multiple independent variables, x's, that we think influence what happens to the response variable. So let's look at an example. I gathered a very small data set, just so it's easy to play around with on the slides and stuff, for high-rise buildings built in major metropolitan areas of the U.S. and was sampled between 1990 and 1992. And the question I want to come up with or try to answer is there a relationship between the number of stories that the building is built and the overall ending height of the building? And then what's your guess? So take a second, think about what you would think the relationship would be. Hopefully it should seem somewhat intuitive to you that the more stories a building has, the taller it is. So we would think there's probably a positive relationship between the number of stories and the building's height. And if you start to think about it, a story in a building is pretty standard height of about 10 feet. So we would think that as the number of stories increases, the building height would go up, and it would go up by about 10 feet. Now, there can be variation in that because you could think about the first floor might be taller than the other floors for a nice big entryway into a lobby. There could be something tall on top of the building that would add to its overall height at the end, like a penthouse, and then a nice big tall spire up into the sky after that. So here is the data. What do we got? 2, 4, 6, 7 different data points, so very small data set. Number of stories, the year it was built, and the height in feet. So first thing we need to do when we get a data set and we want to explore the relationship between the two is what is the x variable and what is the y variable. So y is what we're trying to predict or trying to determine is the response to the other variable. So the y variable is height. We think height depends upon the number of stories. So therefore the x, the independent variable, is the number of stories. In this case, year is just some extra information that we're not that interested in at this point. So then we could calculate the correlation coefficient between stories and height, and if we do that, we get 0.9386. So it makes it seem like there's a strong positive linear relationship between the number of stories a building is and its ending height in feet. So that makes us think that our guess, our hypothesis, was probably correct. But we need to explore that more, so we'll do that in the next video.